Hi everybody, I am Marco, PhD student in physics, and he is Antonio, recently master graduated in computer science. Our mentor is Sébastien Bardier, that is the director of the School of AI and has a strong background in NLP. That is highly related to our project of the creation of an automatic assistant for the IT help desk of Enel. What is the problem? When a customer has a technology issue, he opens a ticket in the help desk. And here, engineers start to collect tickets and start to work in order to solve them. That means a lot of waiting time for users because they have something like 200, 300,000 tickets per year. Furthermore, there are a lot of these tickets that is already seen by the help desk. So it results in a very repetitive and boring work for engineering. So it could be very helpful to have an automatic assistant that could be able to solve the simplest tickets and leave to the engineers only the more difficult ones. That means a lot of reducing time for the user and wasting time for engineers. What happens now is that the engineer receive the question from the user, and he start to collect features in order to categorize the problem. And very likely he spent a lot of time in searching in a similar solution in their huge database. So we need to find a way to find similarities between tickets. This is an example of our dataset. One ticket has a textual description and several categorical features. Our first approach was to use these categorical features to build a vector representation of the tickets, so that if you have a ticket that related to a printer and a ticket related to a phone, you can measure the distance between these two tickets mathematically. The problems of this approach is that in most of the cases, the real difference between two tickets lies into the textual description and not into the categorical feature that could be the same. So we have to, here we started to build more sophisticated models in order to consider the textual description. And we faced a big problem that Antonio is going to explain.
Yeah, now we come to a crucial point. If you work with more than one model, you want to put them on a bar plot, measuring some definition of goodness, and see which is the best, and maybe which is the gap between your best model and the other one. But this definition of goodness actually is not trivial. In our task, intuitively, you can think that a good model is one that, given a new input ticket, outputs more similar tickets. But this is just shifting the problem, because how can I measure the similarity between tickets? It is clear that I need a metric that actually we don't have, because our dataset is just a very long list of closed tickets. So, what you can do when you don't have a metric, you are not able to say, okay, this model is better than this one. How can you make a step without being sure that you are going forward? And the best option is to take the most reasonable route, maybe more than one route at the same time, to minimize risk, to split the investment. And this is exactly what we did. We decided to focus on descriptions that grasp more of the information for our problem. And we tried two different approaches, very different actually, but both promising and very reasonable. The first one, called Dynamax, comes from a paper published this April and accepted at ICLR 2019. ICLR is a top conference in machine learning. This approach is completely unsupervised, and it is actually super fast. Here you can see an example. I'm writing here a IT problem description, and here you are receiving the top 5 similar tickets in the dataset according to the model. You can see that results are pretty reasonable. And this was the first one, while the second one is neural-based, and Marco is going to talk about it.
Yes, we still aim to create a ticket embedding in order to calculate distances. But the difference is that in this way, we create an embedding that is specific of our topic. How can we do this? We built a deep learning model, fed them it with the textual description, and ask him to predict the categorical features. We are absolutely not interested to get the categorical features, but we are interested in the vector representation that is able to create of the ticket. So to conclude, our results are that we built 2 different models that converge to the same results, or maybe almost the same. They both reasonably to sort the tickets, and we left great power of this model is that it's usable not only for IT tickets, but all kind of help support tickets. And we left open this future works that you can create the metric using the feedback of the users, and you can improve the model using the same feedback. And thank you for the attention.